Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about user authentication on a particular computer system. And we will discuss that how passwords can be used for user authentication. These passwords needs to be secured, the passwords needs to be authenticated, and how these passwords can be used for one-time passwords or OTP generation. And again, how biometrics is used for securing the user authentication in a particular system. User authentication in a system is becoming crucial important to the security of the system. If the user is not authenticated for a particular system, then the message or the sense of that particular user access to the resources is modified will none effect on that particular system. So first the user needs to be authenticated by the user authentication process, and then only after any message or access to the resources by the user will get modified according to its use. Now to start this one, a process or a program starts executing in the operating system. And the process or a program execution is now depends on the user's authentication on the particular problem. So if the user is authenticated, then it can support any types of access or process executing on that system. So to authenticate the user, there must be three things or any of these three things. First, that the user possesses something like a key or a card. Next is the user is knowing about some information like the user ID or the passwords. And third is the attribute of the user itself, like the fingerprint, retina pattern or face detection and all. So first we will discuss about the passwords as an user authentication procedure. Passwords or plain text passwords and generally combination with other passwords is the most secure and common way to provide user authentication inside a system. Now first the user, when it is registering in the system, puts a password that is stored inside that operating system. Next, at the time of the login prompt, the user ID and password is given by the user as an authentication process. Now, if the stored password and the input password matches, then the user is assumed to be the owner of the account who is accessing the account. Now, this user ID and password can be implemented in whole of the system as the user is getting logged on, not it can use anything on the access of that operating system. Or it can be done in a more finer grained control. Like for every files in the file system, they are having a password. So for each access to the file, they have to know all the passwords to access that particular file. Even in one extreme, that every access to a file have different passwords. For example, there is a password for reading a file, for appending a file, and another password for updating a file. So in this way, we can provide a finer grained control about the access to a file system or any other access to the resources of a particular operating system. But as we know that more passwords mean more security we are giving to the operating systems and its resources, but sometimes it's because inconvenient, so they are not tend to be used more frequently. So our main goal is to reduce the inconvenience, but if some security is providing some inconvenience, then we should avoid that type of security measures as a user authentication process. Next, we will discuss the password security or the vulnerabilities of the password. As we know that passwords can be a combination of plain text, numerics, alphanumeric characters or any other finger patterns like attributes and all. So the passwords can be vulnerable to any of these three categories. That they can be accidentally exposed, or they can be sold or sniffed like watched by another person, or they can be unauthorized access passed to a legitimate user authorized accessor. So we will discuss about the three issues in details next. So there is a common way to implement the guessing by an intruder on a particular operating system's user authentication process. Say for example, when a user is guessing an authentication, now the intruder can guess it for two ways. First way, to have some information about the user, or have a guessing about the user's personal information. Like many users have their cat's or spouse's name as their passwords. So this general information can be often guessed by any person who can have any information about the user. And another type of guessing that is done by a brute force of enumeration that can be done by a human or a program. So here a combination of these all characters between these passwords are combined to produce the hits on that particular password. Say for a 4-character password which has almost 10,000 variations, and we can say that after we are hitting 5,000 variations we actually crack the password. So for a fast systems, we can guess passwords in every millisecond. It will take only 5 seconds to guess a 4-character password. So smaller the number of the passwords, guessing the actual chances are higher. So brute force and enumerations becomes extremely tough when you use a longer types of passwords, including the lowercase, uppercase, punctuators inside that passwords. So we should take advantage of the long types or long fields provided by the passwords and not use the small characters or only lowercase characters included in our passwords. The next type of protection implementation in the user authentication that an intruder can intrude other than guessing is the surfing or sniffing. Say for any bank account or ATM corner or any kind of this machine we are using that is publicly, so one intruder can look over a shoulder of another user who is actually putting the password into the login scenario. So it is known as shoulder surfing. By actually observing the keystrokes in the keypad, it can gain a knowledge about the password that is used by the user. Another use by this sniffing is known as a network sniffing. So this network sniffing is done whenever the user authentication is done in the time of network. And most of the user authentication is done by this via network only. So the intruder can get easily add a network monitor on that particular network, and then it can monitor any types of passwords or information that is put on the user of the particular network. So it can get sniffed or stolen that particular information on that machine that is resided on the network and use that network after the information has been gathered. Say for an example that all passwords inside the system is stored in a file and that file is being copied for offline analysis. Now a Trojan horse can get into the file and can implement every type of password combination include these files if the file is copied in any machine. So sniffing and surfing is another way the intruder gets into a password other than guessing. Exposure is a severe problem while an intruder is want to guess or intrude in a user authentication process. Say for an example where system provides a strict measurement on the password field that is to be provided by the user. Like they have to use a longer passwords or they need to make of the punctuator longer case and the user case of this password making in such a way that the user forget to remember or it is easier to write it down in some paste. So when the user is writing it down in some place, so it can be read or lost by any of this exposure. So the intruder can get into this piece of information from anywhere of the user's access. So in this way that the security done by this system like in the higher combination of password is less convenient than the systems which accepts a simpler password to implement. The last type of the intruder that can get in the password vulnerability is that the unauthorized access transfer from an authorized user. Some systems provide that only a user ID is valid for a user only. So it is done for not only making the system inconvenient but to secure the system in every possible way. Say for when the user ID is not shared among the users, so whenever there is a user ID is shared among the users, say this user ID is used by 3 of the users and they are making their passwords and can get into the actual accounts. So if there is any problem with any of this user ID, so it is very difficult to detect that which user is actually making the wrong statements or wrong user authentication because all 3 of the users are sharing the same user ID. So now protecting against this kind of problem or failure or termination of an user authentication, the user ID is strict for only one user inside a system. So that whenever a user is having then its user ID, so it is very easy to implement and detect that which user is causing the problem and take measurement against the security measures of that particular user. Some users share their user ID with their friends because of the convenience that they can make to account where they are sharing some information. But due to the system security, it cannot be done because the user ID cannot be shared, so that an authorized access users cannot illegally or accidentally translate its user authentication to an unauthorized access users. Now, passwords can be either generated by a system or can be generated by a user combination. Now, the system generated passwords are not easy to remember and thus it's very complicated. But the user generated passwords are easy to remember, but it is also easy to be guessed by an intruder. So the system generated passwords are sometimes used by the user, but which is written in some place which can again be read or lost by the intruder. The next measurement that is taken to secure the passwords is for aging a password. When we are taking aging a password, that after 3 months or a specific period of interval, the password need to be get changed. Sometimes a user in this case toggle between those passwords. Now, if there is a checking measure that n times the passwords are stored in a file and every time it is toggling for the next use, then the user should be informed that it has been used for more than one time. So it should not choose any of the password combination from the previously used passwords. So in this way, aging can be prevented between this password selection. Another ways of this prevention or this vulnerability is that choosing a password from each network to another network. So when a user is using an account, then this information is not used logging into another account. In one extreme, the password could be changed from one session to another session. That is, every password must be unique for every session that is used by the user. So whenever at the end of the session, the user needs a prompt that will tell them to change the password, which they will require at the next session start. If anyhow the intruder has intruded about the password and gained its knowledge, so it cannot actually enter this session with this now invalid message, either a legitimate user or an unauthorized access of that particular user. Now we will move to our next section, that is the security of the password that is provided by the user and the operating system. One problem that is associated with all the approaches that is using the passwords as user authentication is for keeping the password secure within the system. How can we keep stored this password secure within the system and the same password is being used for authentication for the user? So if it is stored inside the system, then any intruder can intrude in the system and get information about the user authentication. So when this type of scenario is happening, a hashed function is being used on the passwords to produce a hash value that is then stored on that particular operating system on that about the passwords, so that the passwords cannot be read by any of the intruder on that operating system. Here the password first stored and input by this user. Next, on the password, there is a hashed function which is easy to compute but difficult and impossible to invert of that particular password. Say for an password X which is inputted by the user, now fx is a value or a hashing function that is performed on that particular password. Now this hashing function is easy to compute and produce a hash value based on that password, but if it difficult and impossible to calculate x from this fx. So after this hashed functions values are stored in the operating system, so they can know that which passwords can be generated. So now at the time of user authentication, the user is again inputting the password, then the hash function is being used on that password, and if these stores of the value match with this hash function of the inputted value, then the user is authenticated access to that particular system. In this way, the hash function is used to generate the passwords and used to use this value as an hashed value of the password to have a more authenticated version of this user other than using that passwords as a plain text. Now the problem with hash function is, if the hash function is easy to compute and is communicatable to the user, then anyone can compute an hash value according to its password. So these hash values are stored against the password in a file so that the file can be copied by the intruder, and again the hash function can be fastly run on that particular file, so generate the hash values. So now, as the hash function can generate on the dictionary that contains the word which is containing the passwords in that particular operating system, so the dictionary is used to generate the hash values based on that hash functions, and if the passwords matches with any words in the dictionary, then the password will get cracked. Along with that, we know that the Unix caching or this hashing mechanism becomes extremely popular. So the cracker previously known about this information that which password has been already cracked, so it kept it in another information file. So next time the password is produced, it's checked for the file that is cracked one, and if it is not found, then it produces a hash function on the dictionary value. So in the version of the Unix nowadays uses a salt, that is a random number that is associated with each of the hash function. Now as the salt is associated with the number, so if the plain text is used for the passwords by say 2 of the users, so if the passwords are same but the hash functions will be different for using this salt number, as the random number cannot be same for 2 of the users. And it also makes the difficulty of this dictionary hashing function by the intruder, because it adds every word and its hash value of passwords with the salt number association. So now the intruder cannot have easily intruded by dictionary hashed functions which will not match with their passwords, as they contain the salt number within them. Now the newer versions of the Unix uses only the super user to control this of the hashing function and produce the hash values. So no other user other than the setuid, if it is set to the root, can use the hash functions. Another problem with Unix implementation of this hash function use, they give performance advantages of the first 8 characters of these passwords. So we should take advantage of these first 8 characters and put as much combination of a lowercase and uppercase character to get a password in the Unix system. Say for an example, if the user phrases are easy to remember, so we can use each letter starting off that word on a phrase and then make a combination of user and lowercase character to produce a password. Say for a phrase that my mother's name is Kane. So we can make this a password that's capital M, small m, capital N is capital K. So MMN is K is easy to remember, but it is user intruder, it will be difficult to crack. Some Unix system providers use a spaces to the password to get the passphrases as containing these differences between the two phrases. But it does not use the spaces, as it includes a space for the intruder to get into the password capability. The next type of password security we can provide is a one-time password. In one-time password, the user uses a set of paired of passwords. Other than using a single password that is used for authentication, that is stored in the machine and is inputted by the user, here we are using a pair of password for this purpose. That one part of this password is generated by the system and the other part must be generated by the user to get match of this paired of the password. So here the system user is challenged that it has to ask and question by the system, and the answer must be given by the user to generate that particular pair which is unique for that use. So every time this pair is using, it is a one-time password, or that no other user can be able to use it even if they know the pair of password of that particular use. Even if the same user is using the application again, so it will have another pair of password for that use of the next session on that particular application. So these one-time passwords can be generated by a combination of PW and CH, where the PW is generated by the system and the CH is the challenge that is to be given to the user to make an hash function on h/pwch is that the pair of pwch is given to the hash function to produce a hash value, and that will be matched with the hash value that is given by the system and the user. So in this way, one-time password is generated. So the next time the user is using the application, a new CH will be generated by the system and passed it to the user to again calculate the hash values on the new pair of PW and CH. So in this way, the hash function is used to generate the one-time password, which gives more security because it cannot reuse even if the same user is using it. Now, it uses the PWCH combination with a combination of PIN, that is a personal identification number. The PIN is used by this PW, that is system generated, and this PIN and CH combination, the hash function, is used to generate a one-time password. Now, the one-time password, other than a single factor, that is only the password and the CH, it is better to use a two-factor authorization. Two-factor authorization includes that other than the user ID, the password that is given by the user should have two parts, like any USB or a modem or something, retina pattern or face detection, along with the password or the PIN. Here no. So the two-factor authorization provides that something you have and something you know, and the combination is used to generate the one-time password. Now, this one-time password is often used by a hardware calculator or a code book or a software display of this numeric keypad. Now, whenever this keypad is used, then the matched data will be given to the system, and then it is matched with the user's PWCH combination. So now that the used combination will be used by the system for an user authentication for the user for single use of that application. So the OTP is extremely useful, and the transaction of any bank's information or any of the application that require financial or corporate functions. So now we will use our next type of the password, that is a biometric password. So this biometrics is used as a password where the face prints or the fingerprints, that the retina patterns or even if the face of the user is being stored in the system, and later it is matched when the user is want to log in to the particular application. Now it is being used in a security information or the security logging at the office gate or any other bank information of this SSL users. Now, whenever this biometrics is used, it is used as a data center to store all the data of the biometrics of a user. Now, the finger width, the finger length, the finger lines patterns, all are stored in this data center, and which can be calculated over time to increase its efficiency. Say for the over years, it will increase that which location the finger is printed, so that if the user is printed its finger at different location of the finger pad, so that also the user can be authenticated based on the information. So it is about this learning mechanism of an artificial intelligence which is used with this biometrics to produce an actual effort to make the user authentication possible. Now, when the multi-factor authentication is used, such as use of the biometrics of fingerprints, user ID, passwords, all three you need to log into an exact application, so it will be a very secure way to authenticate a user. So while placing one hand in the finger pad, other facing this USB modem to get into the application, and after that typing and password in the numeric keypad of the software provider will then get authenticate a user to get applied to a particular access to rights. Now this type of information access authentication is used in very secure communication, like at the gate of a very diamond protected environment or a bank or any office gates of the ESSL environments. So this is all about the user authentication via the password, password security and biometrics use. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.